Okay, welcome to 4.2 to 4.6. This is going to be a quick quiz. Let me create a new document. Today is October 25th. New document. All about chapter 4 oxidation reduction reactions. I'm going to create a table, memorize it. You'll know everything, almost everything for the rest of the chapter. Reactions can be either oxidation half or reduction half. Basically, in an you can identify if it's oxidation or reduction through four things. Okay. Let me just write the table for you. And oxidation number. Okay. So this is our table. In an oxidation reaction, obviously, if something's being oxidized, then the number of oxygen atoms will increase. If something's being oxidized, it loses electrons. If if something's being oxidized, its charge will increase. If something's being oxidized, its oxidation number will increase. And reduction will be the opposite. The reactant in an oxidation reaction is called the reducing agent, and the reactant in a reduction reaction is called the oxidization agent. Let me explain a bit. First, I'll give you an example of, let me see, ZNO plus C to produce Zn plus CO. This is what we call a redox reaction. It's a mix between reduction and oxidation. Why? Why is this reduction and oxidation? ZNO was reduced to Zn. So this is a reduction reaction. It lost O. C gained O. So this is called oxidation. This is oxidation. This is reduction. So in total, we call this a redox reaction. This is an example of identifying a reduction oxidation reaction from the amount of oxygen atom. How about electrons? A good example is, for example, I'll start with oxidation. Cu to produce Cu2 plus and 2E minus. This is oxidation. Why? Because initially the copper started as copper. In its products, it released what? Cu2 plus and 2 electrons. So it lost 2 electrons. You can memorize it by doing this mnemonic. OIL. Oil. Oxidation is loss. How about reduction? For electrons, a good example would be Ag plus E minus to produce Ag. This is reduction because it gained an electron. It gained an electron. So it can also be memorized using the mnemonic RIG. I think many of you know what an oil rig is. Oxidation is loss of electrons. Reduction is gain of electrons. Okay? This is, we call oxidation half. This is reduction half. Because together they make up one full reaction called a redox. Okay? Go through the notes. Just one thing I have written in my copybook. CQD1 over here. Okay. You should read over the notes really. CQD1, CQD1, CQD1. Where is CQD1? QD1. Or do I have? How do I have it in my copy? But it's not here. I don't know. These are all past papers, by the way, huh? My advice to you is study all of these. There are how many past papers? 19? 19 questions? Yeah, problem solving session. Honestly, do all of these. Really, wallah, do all of these. But where are their answers? Honestly, we should find these answers. Oh, I'll look at this later. But if you're in the WhatsApp group, I'll talk about this sometime later. But for now, I don't know. I'll email my teacher about that. Okay. Anyway, I can't find the question that I have written here. But for a redox reaction to occur, like what I have written here on my notes, is I had a solution of CuNO3 and I dipped a zinc rod in it. And then I had another one where it was ZnNO3 and I dipped a copper rod in it. Okay, and basically zinc is more reactive than copper. Okay, so the one that actually took place was the one where I had the zinc rod. This one didn't take place. So the spontaneous reaction was this one because zinc is more reactive. I don't know why it's not in the notes, but basically what happens is copper nitrate is blue. So when you have zinc solution, basically what happens is this: the zinc begins to displace it. So basically, how it works is Cu 2 plus gains 2 electrons and it becomes Cu solid, and this Zn loses 2 electrons and starts becoming aqueous. So basically, this is solid zinc when it's put with copper nitrate, because you're going to see a lot of these where you dip a rod into a solution. Okay, you're dipping. These redox reactions usually happens between two metals, but this is the half. What happens here is the zinc turns into Zn2 plus. It was zinc solid, turns into Zn2 plus, and copper 2 plus. It was an ion, right? CuNO3. This is a solution. It's a compound, so obviously it's an ion, Cu2 plus. It turns into Cu. These are what these redox reactions are. In general, this is what happens. So the net ionic in this case, like the total reaction, you just cancel E with E. You're going to get Cu2 plus Zn gets you Cu plus Zn2 plus. So if you see here, they kind of swapped roles, right? It was aqueous, it became solid, right? Then this zinc was a solid, it became aqueous. So here, if you observe the reaction here, this rod will begin to decrease because it was solid, it's turning into aqueous particles of zinc. And this copper, the solution begin to decrease, and it was blue, so what happens? The blue color fades. This was an experiment we covered in class. Okay? And what forms? Since it's zinc, it forms red-brown deposit from the copper particles because they start to become solid. And what happens? Zinc dissolves. The rod begins to dissolve. Here, no reaction. So, what this experiment shows you is that for a spontaneous reaction to happen, the solid one, the reducing agent, is it reducing agent? It's oxidation. The reducing agent, because this one's being oxidized, right? It's losing electrons, so it's oxidation, right? Oxidation is loss of electrons. This is the oxidation half. This is the reduction half. And the overall redox would be just mix them together, cancel E with E. This is the redox. So the reducing, for a spontaneous reaction to happen, the reducing agent has to be more reactive than the copper. There is a way you can memorize it. You should know there's a table. Usually it's given, okay? But this is the table. I have it memorized. Meets on December 1st. No person here. No person here. H here could argue. So this is the reaction table. Okay, I have it memorized. Our chemistry teacher made us memorize it like this. Canalica meets all zebras first. No person here could argue. That's how I have it memorized. I don't think you should memorize it. I mean, I don't think you have to memorize it because usually these are given in the exam in questions. You're gonna see later. For now, you don't have these types of questions. Anyway, so we covered electrons decreases in oxidation, right? You lose electrons in oxidation. See, these are oxidation. This is oxidation. Did I write down? Yeah, this is oxidation half because it lost. This one's reduction because it gained. The charge increases. Okay, yeah. For oxidation, it was 0. It lost 2 electrons. What's the new charge? 2 plus. So it went from 0 to plus 2. Isn't that gain? Yes. How about reduction? It was plus, it went to 0. It went from plus 1 to 0. Isn't that going down? Yes, so it's reduction. Oxidation number. Hello, you're going to see oxidation number in a bit. Uh, Actually, no, we don't really cover it. But you should just know the oxidation number increases for oxidation and the oxidation number for reduction decreases. Type. Let's see if something is redox or non-redox. CuCO3. For a redox reaction to happen, it needs to be it needs to have an oxidation and a reduction half. Before continuing, you should know that acid-base reactions are never redox. It's somewhere in the notes. Not all reactions. Okay, an oxidation can be defined as the gain of oxygen during combustion. Something reaction. Yeah, this is very important. Oxidation and reduction are always together. You can never have oxidation or reduction alone. This is why we call them oxidation half, reduction half. You can't have half a reaction. Redox reactions don't need oxygen gas, right? You can have it just with charges. Yeah, you don't have to react it with oxygen gas. Okay. These are like I told you guys. Read the notes, huh? La 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 la. Man, it was one of the questions. I have it written on my copybook. It was like a multiple choice. Yeah, here. This one. Which of the following is redox? CQD1. Yeah. Yeah, CQD1. Oh, it is here. How did I not find it earlier? Okay, anyway. This one is non-redox. Copper becomes copper oxide, CO2. Did CO3, you can't have wait. Okay, yeah. CuCO3, CuO. CuCO3, it already has oxygen in it. Here, you're just decomposing it into two things, It's not redox. What's reducing? What's oxidized? You can't see CO3 is being reduced because, it's usually between two things. You can't just have a take. Do you get what I'm trying to say? No, here you're just decomposing. There's no reduction. There's nothing being reduced, nothing being oxidized. It's one thing being decomposed into CuO or CO2. It's non-redox because it's not like nothing's happening. ZnOHCl. This is a base. This is an acid. You might say, oh, zinc oxide. It reduced. It lost its oxygen. But HCl gained its oxygen. No, that's not how it works. This is non-redox because we always said any acid-base reaction is never redox. Okay. 2Cu plus O2. Okay. Here, Cu gained an oxygen. O2 was reduced to O here. So this one gained, right? This one lost. Redox. Zn plus 2HCl, ZnCl2H2. So you're going to be like, how did this happen, right? Okay, here you had Zn. It became ZnCl2. What is ZnCl2? ZnCl2 is Zn2 plus and 2Cl minus, right? So didn't the charge go from 0 to 2 plus? That increased, right? How about here? HCl or H. Here in HCl, it's actually H plus and Cl minus. H2, it's 0, right? The charge of H2 is 0. So it went from 1 to 0, so it decreased. So that's the reduction. So it's oxidation, reduction, redox. They might not make sense now. I know still at the start, I'd see why they won't make sense, but you just try your best to understand. Question 2. Okay. Here they gave you Br and it's losing electrons. So obviously it's oxidation half. Bromine are what? To bromine water. I think Br2 is called bromine water. Aqueous, cause yeah. Bromine is what? Obviously it's being oxidized. If it's being oxidized and part C they were like, what is this? What is bromine called in this case? It would be the reducing agent. The thing being oxidized is always the reducing agent. Very straightforward. And Cl2 is gaining electrons, so that means it's reduction half. And that means what's happening to chlorine is being reduced. Question 4. You have here Cl2 plus 2Br minus Cl minus Br2. Anytime you have like this when the charges are being swapped. It's like here it was Cl0, it became minus, and then here it was minus, it became 0. This is always redox. Which one's oxidizing? Which one is reducing? You're gonna ask yourself, which one? The oxidizing, the oxidizing agent always loses. I know it might sound weird, but the oxidizing agent is the reactant in the reduction reaction. Which one's being reduced? It's going from 0 to -1. So Cl is being reduced. That means it's called the oxidizing agent. How about the reducing agent? The reducing agent is always the one that's taking place in that's taking part in the oxidization reaction. Here it's oxidizing reaction is gain in charge, right? Here was negative, here it became 0. So -1 to 0, it's gaining. So this is the oxidization reaction. And what's the reactant called? The oxidization reaction is called the reducing agent. This is 4.2 done. هلا 4.3. هلا 6.2 شو 6.4.2. This has to do with the galvanic cell. In chemistry, you can convert chemical energy to electric energy and vice versa. To convert chemical energy to electrical energy, shit, you can do so through a galvanic cell. Okay, a galvanic cell. Basically, a galvanic cell. Shit, man. Okay, yeah, I'm back. So, the galvanic cell makes use of the reduction and oxidization reactions to produce electric energy. Basically, in one cell, you would have, let's say, for example, copper nitrate. This is just an example of a setup of a galvanic cell. And in another one, you would have AgNO3. You know, if you dip a copper strip here, or sorry, a silver strip, no reaction will take place because the strip or the rod has to be more reactive than the solution. Like remember over here, when we did this won't work. This one here doesn't react because copper isn't more reactive. It has to be zinc strip because zinc is more reactive. So you should know copper is more reactive than silver. Okay. So if you add a silver strip here, am I recording? Hello? Yeah, if you add a silver strip here, it won't react. So you're gonna add a copper strip here. Over here, you're gonna add here a silver strip. I'm gonna explain everything in a sec, okay? I'm gonna explain everything in a sec, but just give me a few seconds. Over here, you're gonna connect these two rods to, let's say, a light bulb from physics, and let's say an ammeter to measure electric current, and you connect it over here. Then you're gonna connect these two circuits. You need to close the circuit because it's opened over here, right? You're gonna close it by adding a salt bridge. Without the salt bridge, the reaction cannot take place. This is the salt bridge. So here, throat hurts a lot. What happens is the following: CuNO3 Cu. CuNO3, and here it's Cu2 plus, right? It's gonna react the Cu to form Cu2 plus and 2E minus. Because you guys know copper has more reactivity than silver, right? So copper here is gonna react. Here, silver doesn't react, but you have the ions here, Ag plus. They're gonna be the ones reacting. Okay, Ag plus E minus to produce Ag. Let me explain. So this copper strip that you dip here is gonna react, since it's the more reactive one, and it's gonna form copper ions. So don't you think the copper rod is gonna start to melt? It's gonna start dissolving. It's gonna like its length will begin to decrease. Here, our silver ions from the solution are gonna be reduced to form Ag. So isn't the length of this strip gonna grow? Yeah. So here you have oxidization because it's losing electrons, and here you have reduction. So you have a redox reaction going on here. Basically, you switch on when you close the circuit with the salt bridge. Here's what happens: the salt bridge usually filled up with any salt, like I don't know, you can say any Cl. We don't care, any salt. But essentially, what happens is this: you now have electrons, right? Because you need an electron for a circuit. You're gonna see now this solution here will have Cu2 plus and 2 electrons. So it's gaining positive Cu2 plus, right? Here, it's Ag plus, it's losing. So here it's losing Ag plus. This is why we have the salt bridge. The first function of the salt bridge is to close the circuit. But the second function, it's to balance it out. Here, you have extra positive charges. So what do you think is going to happen? You have Na plus in the NaCl and you have Cl minus. Since you have an increased amount of positive charges here, the Cl minus will move to the left. Since we have an increased amount of, we're decreasing our amount of positive charges, we should obviously move some positive charges to balance it out. So Na plus will go to the right. Since we have negative charges moving to the left, we're going to call this the negative rod, and we're going to call it the anode. Since we have positive charges moving towards here, we're going to call it the positive rod, and we're going to call it the cathode. What do you need to know? You need to know that the anode is always the more reactive one. The cathode is always the least reactive one. So they tell you zinc and copper, whatever, and then they tell you zinc is more reactive. Sorry, zinc is the anode, copper is the cathode. Then they ask you, what is the direction of current outside the solution? And then they say, what is the direction of electrons? You know that current always moves from positive to negative. So it's going to move from cathode to anode. So in this case, it's going to move from Ag to Cu. Right? From Ag to Cu. And what would be the direction of electrons? You know, electrons always moves from negative to positive. So it's going to move from anode to cathode. So it would move from anode to cathode. So from Cu to Ag. And then they're going to say what would be the direction of movement of the ions in the salt bridge. You would say, if they told you it's NaCl, you would say the Na moves towards the anode, and the Cl moves towards the cathode. You'd say it like that. And obviously you'd have to specify which one's the anode from the cathode. In this case, you say Na plus moves towards the Cu, and the Cl moves towards the Ag. So hello. Let's solve these questions. Here you have MgSO4, CuSO4, magnesium rod, copper rod, and it's important to know that magnesium is more reactive than copper. Okay, like I told you previously, if you want to memorize the reactivity, it goes like this. Okay, Cananica meets all zebras first. No person here could argue. So that's not important here. What they're saying is why is there no voltage? Obviously, because this circuit is not complete. It needs a salt bridge. Okay. Question 2. Which of the following is oxidation half? Obviously, oxidation half is going to be this one because it lost electrons, right? This one here, it's this is base acid. This is just a normal reaction. This one here is redox, because I'm going to show you a new way now to know if it's redox or not. But let me finish this quiz. This one here, it's gaining electrons. This is reduction. We want oxidation half. This is reduction half. And this one here is redox. Question 3. Which of the following reactions takes place spontaneously? For a reaction to take place spontaneously, and this we had a question similar to this in grade 10 when we had the halogens. And remember that the halogens, you would always have it like this. You would have it like you'd have halogen plus halide to produce, let's say halide, to produce the halide plus the halogen minus. Like it would be displaced. You get what I mean? Like the charges would be displaced. So remember, it would always be the one that has no charge should be more reactive. So here they listed it from most reactive to least reactive. They're saying which would take place spontaneously. Our teacher explained it like this. She said use the gamma rule. It basically goes like this. Okay, you can do this. Basically, this one reacts with this one to form this and this. It has to obey the gamma rule. Gamma rule, how do you write gamma? You start from the top left, go to the bottom right, go to the left, and go up. Okay? You can use this rule, especially if I have a table. So like here, Cu and Zn2 plus. Where's Cu? Cu is here. Zn2 plus is here. To go from Cu to Zn2 plus, you have to go up. So obviously that's wrong. Okay? Zn, Cu2 plus. So go from Zn, where's Zn? Zn to Cu2 plus, you go down, then go to the left, go back up. This is a gamma. So this would be correct. أنا for me ما بعمل لا gamma لا بلوط. I just look at the element. I see, is it more reactive? The one that has zero charge at the start should be more reactive than the second one that has a charge. Like the Cu here, is it more reactive than zinc? No, so this can't happen. Zinc, Cu. Zinc, is it more reactive than Cu2 plus? Yes, so it can happen. Cu, H plus. Cu, is it more reactive than H plus? No, H plus is above it, so no. HCu, let's see, H, is it above Cu? Yes, okay. AG is here, H is up here, so obviously no. Zn, Ag, Zn, Ag. You're gonna say, Tabulid, isn't Zn above Ag? Okay, look. It has to be zero charge with plus charge. Is there a plus charge? You know, they're both 0, 0. Is this called a spontaneous reaction? No. They have to displace their charges. So this one here should have a charge. Okay? Should always be something with a charge, and the products would be just the charges swapped. Okay? That's how it works. Type. Sometimes they might trick you and put them like in a different order. It's like here. They might rewrite this like this. People would just look at Cu. They would look at the first element and see if it's more reactive than the second element. Like here, Cu isn't more reactive than Zn, so they'd say this is wrong. But no, you always look first at the one that has zero charge. Sometimes the element that has zero charge may be written second. So please make sure you read the equation properly. So Zn 0, you read which one has 0, it's Zn. So you see, the one that has zero charge, is it more reactive than the one that has charge? Zn, it's more reactive than Cu2 plus, so it can obey the gamma rule. Okay, question 4. Okay, a manganese rod is placed in a 1 molar manganese nitrate solution. Manganese nitrate is MnNO3. Okay, a tin rod is placed in 1 molar tin nitrate solution. So I think it's Tr, I don't know. The two half cells are connected internally by a salt bridge and externally by a voltmeter. So it's the same setup we had. We have the manganese nitrate here, and we have Mn. And you have, I don't know, tin, I think Ti. Let's just say Ti, NO3 over here, and it has a tin rod over here, Ti. And here you have manganese rod. And they're connected with the voltmeter, ammeter, whatever. And then here you have the salt bridge. It's the normal stuff we have. Okay, the voltmeter reads 1.04, and it shows that the tin is the positive terminal of the cell. So the tin here is the positive one. What does that mean? That means tin is the cathode. And they're saying this means manganese is more reactive than tin. And we know the one that is more reactive always means what? That one is the anode. Means manganese is the anode. It's the negative one. In the described cells, electrons flow from what? Electrons flow from negative to positive, right? Which one's negative? The anode. Which one's positive? The cathode. So it goes from negative to positive. So it goes from the manganese to the tin. And electric current always flows in the opposite direction. If they asked for what is the direction of electric current, it would go from positive to negative. So cathode to anode, so tin to manganese. What is the cathode? We said it's tin because it's positive. And which one's the anode? It's manganese because it's negative. The cations and the anions. When they say cations and anions, they're talking about the salt bridge. Always know that the cations move towards what? The cathode. Because cation. Cation, cathode. Anion, anode. That's where the names came from, by the way. Why do we call it anode? Because the anion moves towards. Which one is a cation here? It's a positive one, so it moves towards the tin. And which one's the anode? It's the manganese, the negative one. So the anions will move towards. Give the oxidation half reaction. Always know that the oxidation half reaction takes place at the anode, and the reduction half reaction takes place at the cathode. Must memorize these. Okay, they help you with solving way quicker. At the anode, what's happening? Manganese NO3. So it goes from Mn. It was 0. Obviously, it was a solid. And what happens? It releases 2 electrons. It becomes Mn, 2 plus, and releases 2 E minus. Remember, oxidation is when what? You release electrons. Always. Oxidation, you release electrons. Here, so obviously you need to put state symbols. This would be aqueous. And electrons, you don't put their sign. They're just like this. Okay, so Mn solid. Obviously, it was solid because it was a strip. And then became aqueous. Some people, you might have difficulty knowing what the charge of manganese is. In the exam, man, they're not going to give you manganese. They're probably going to give you copper and silver or something easy. But this is just to test you. Then for the tin. Oh, tin, turns out tin is Sn. I don't know how I got Ti. Okay. Tin. Tin is the cathode. So obviously, they want the reduction reaction. Where does reduction happen? It happens at the cathode. In reduction, you gain electrons. So you write always your element with a charge. You always write your element with a charge. Of course, it's aqueous. You always add electrons. When it's reduction, you add electrons to produce that same element, but with no charge. And now, obviously, it's turning into the strip. It's extending the strip, so obviously it's turning into a solid. Okay? So, to sum up, I know it still might not be clear, and I completely understand because it's a bit of a difficult concept. The more reactive one will always dissolve. When I say dissolve, it means its solids turn into ions. So the length of the metal will decrease. So basically, that's how it's turning into ions. And to turn into ions, it needs to release electrons. Because you should have the charge on the left should be equal to the charge on the right. Here you have 2 minus 2, 0. So it should be, if it's 0 on the left, it should be 0 on the right. That's why we add these electrons to balance out the equation. Same thing here. Obviously, if the length of the metal will decrease, then the length of the metal here will increase. So that means the ions are turning into solid. And what are the ions? They're Sn2 plus. You want to turn it into solid 0, right? How do you turn it into solid? If here you have the charge is 0, here you have the charge is plus 2. How do I change this plus 2 into 0? To put minus 2. How do you minus 2? You just add 2 electrons. Okay? Question 5. Question 5. It's not opening. Okay. An aluminum rod is placed in a 1 molar aluminum sulfate solution, and a zinc rod is placed in a 1 molar zinc sulfate solution. The two half cells are connected by a salt bridge and externally by a voltmeter. The voltmeter reads 0.9 volts, and it shows that zinc is the positive terminal of the cell. What does this mean if zinc is positive? That means zinc is the cathode, right? And if zinc is the cathode, that means aluminum is negative and it's the anode. What do they want to ask? The current passes from where? Always from positive to negative. Which one's positive? The cathode, zinc. Which one's the negative? Anode, negative, aluminum. So zinc to aluminum. Electrons go the opposite way. They go from negative to positive. So from aluminum to zinc. Which one is the cathode? Which one is the anode? Obviously, the cathode will always be the positive one. And the anode is the negative one. Simple as. Write the oxidation half reaction. Remember, oxidation half reaction always takes place at the anode. Okay? How do you write an oxidation half reaction? You take what you have. What do I have? I have Al. you always start with a solid. It's dissolving, right? The rod is dissolving. Dissolving to get me what? It's the same thing but just ions. So Al becomes 3 plus. You guys know because the subscript here is 3. That means the 3 is for the aluminium because we crisscrossed it. Aluminium. And it turns into what? Aqueous, obviously, because it was solid dissolving down to aqueous. And how do I balance this out? This 3 plus, I add 3 electrons, right? How about the reduction half? You know, the reduction half always takes place at the cathode. And what does the reduction half do? It changes it from the ion into the solid. What's the ion in this case? Zn, you know, Zn is 2 plus, guys. So this Zn2 plus, it was an ion, so it was aqueous. It turned into zinc solid, right? It's making the length of the strip longer. How do I balance this out? Zn2 plus to get Zn. You have here 0, here I have plus 2. I need to subtract by 2. How do I subtract by 2? I add 2 electrons. Part E, how much energy is released by the cell when 2 coulombs pass by? Okay, they don't ask this. Please you don't need to know this. But in case they do ask it, in case they do, from physics, W is equal to QV. They gave you the charges too. And the volts up is 0.9. You get 1.8. You're not required to know this for chemistry. However, it may come. So I gave you the formula just in case. Okay. Here we have a redox reaction. They told you 0.6 moles of zinc reacted with chromium Cr3 plus. Calculate the number of moles of chromium. Okay. You have 3 zinc. How much is given? 0.6. So it's actually 0.6. In the reaction, how much chromium is deposited? 2. We want to know when it reacts with 0.6, how much is deposited. When you react 3 zinc, you get 2 chromium. How about if I react 0.6 zinc? How many chromium will I get? X, right? So what do? You cross multiply. You can get 3x is equal to 1.2. You're going to get 0.4. Calculate the mass of chromium. We found the moles. How do you find the mass? It's m over m. So just multiply the mass by its molar mass. They gave us that chromium is 52. You just multiply the moles by 50. So the moles is 0.4. The mass, we don't know it, but the molar mass of chromium is 52. You should get 20.8. 0.4 times 52. You get 20.8. Okay. Lead metal reacts with copper ions Cu2 plus, but not with nickel. So lead reacts with copper. So lead Pb is more reactive than copper, but it doesn't react with Ni2 plus. So it's not more reactive than Ni2 plus. So you could say it's like this. Magnesium reacts with both copper and nickel. So magnesium is greater than copper and it's also greater than nickel. Drag and drop to arrange the following reactions in decreasing tendency for both the metals to lose electrons. Without looking at this, let's see. Which one here is the strongest? Obviously, it's going to be magnesium because magnesium reacts with everything. So magnesium would be number 1. Let's see number 2. Would it be lead? No, because nickel is more reactive than lead. That means nickel is the second most reactive because since we know lead reacts with copper, but it doesn't react with nickel, that means nickel is more reactive than lead. And if lead reacts with copper, and we know that nickel is more reactive than lead, that means nickel should also react with copper. That means nickel reacts with everything except magnesium because we said magnesium is more reactive than nickel. So number 2 is going to be nickel. How about number 3? Is it going to be Cu? No, because we know lead is more reactive than Cu since it reacts with copper. So that means lead will be my number 3. And obviously last will come Cu. Very easy. This is 4.3. Before continuing to 4.4, I don't know if they're going to ask it in 4.4, but I found an easier method. Actually, not no. When we get to 4.4, because I want to explain what oxidation numbers are first, and then you'll understand it way easier. Okay, for 4.4, it's just studying an electrochemical cell. It's the same thing we just did, but I'll just repeat it as سريع يعني. A copper rod is placed in 1 molar copper sulfate solution, so copper sulfate, and the silver rod is placed in 1 molar silver nitrate solution. So you have copper here, Cu, and you have Ag here. They're connected by salt bridge and by voltmeter. The voltmeter reads 0.46. Okay. They didn't tell you here which one's positive. You're required to know it on yourself. It is important that you know Cu is more reactive than Ag. It was mentioned in the notes, mentioned in the book. It's mentioned everywhere. Cu is more reactive than Ag. This is the one you have to know by heart. Okay, فهمنا, you don't want to memorize all this, but at least know that copper is more reactive than silver. The rest, 99% of the time, will be given to you. This is the only one that you actually need to memorize. Okay? If you know that copper is more reactive than silver, that means always the more reactive one is the anode. And I mentioned this before. So since the more reactive one is copper, that means copper is the anode, silver is the شو اسمه is the oh, I'm so sleepy. Silver is the cathode. Okay. Here they're asking you to label. They gave you the direction of electrons and they gave you the direction of copper. You know that the current, sure, they gave you the direction of copper as the current. They gave you the direction of the current. You know that the current always flows from positive to negative. So here it's going towards the negative one, right? Which one's negative? We know our anode is negative, our cathode is positive. Okay? Which one's my anode? Copper. So that means it's going towards what? The copper rod and the copper sulfate solution. Electrons. Electrons, this is for current. Electrons move from negative to positive. So here, the electrons are moving towards the positive one. And which is the positive one? It's the cathode, which we identified as Ag, right? We identified the cathode as Ag. That means here is going to be the silver rod and the silver nitrate solution. Write the oxidation half reaction. Oxidation half reaction takes place at the anode. How do you write it? Basically, the rod is dissolving into ions and an electron. What's the rod here? It's copper. At the anode, we identified this as our anode and this as our cathode. Cu, this is my anode. It turns into, it's dissolving. It was solid, it's dissolving into ions now. So Cu2 plus aqueous. And to balance it out, what I have to add? 2E minus. The reduction half. The reduction half takes place at the cathode. At the cathode, I have silver. And in the reduction, what happens? It turns from ion into solid. And to do that, I need to get rid of this plus 1, balance it to 0. How do I make plus 1 into 0? I have to subtract 1. So you put plus E minus. The cations move towards the what, while the anions move towards the what. Very, very simple. It's cat. So cations always move towards the cathode. Anions move towards the anode. That's it for this one here. That's 4.4. Now to 4.5. Okay, 4.5 now. It's all about the E0 and the electromotive force. Basically, I'm going to sum up this whole section in maybe a few sentences. E0 is basically, it's called reaction potential. And basically, it's the one with higher E0 is more reactive. That's all it means. So here in this case, you have E0 of zinc is negative 0.76, and the E0 of copper is 0.34. Yeah, so I was saying the E0 value determines the reduction potential. So the higher, I'm going to write it like this. The higher E0 is, the more likely it gets reduced. I'm going to underline reduced. So it's called reduction potential. Here, E0, E0. The one with the higher reduction potential is 0.34. So if you were to put these in a galvanic cell, the one that would be undergoing reduction would be copper. So this one would be undergoing reduction. And in our galvanic cell, which one would go through oxidization? Which one would go through, let's say this is my anode, and this is here my cathode. Which one would go through oxidization? Which one would go through a reduction? Remember that the oxidation always occurs at the anode, and the reduction always occurs at the cathode. So since reduction is occurring at the cathode, that means copper is going to be my cathode, and zinc in this case will be my anode, because it's not undergoing reduction. It has the less reduction potential, so it's not going to be reduced. Instead, it's going to be oxidized. And which one has oxidization? Always the anode. So that means zinc is going to be the anode. How do you find E net? It's so easy. E net is so easy to find. Basically, you take your positive one and you add it to the opposite of your negative one. So 0.76 and you get 1.1. Okay, you just add them, but before you add, you have to make both values positive. That's it. Like, wallah, it's so easy. Question 2. Okay, here you have. Actually, no. You know, I'm gonna get. There's a formula you need to know for E0. To find the net E0, it's Eox plus E reduction. Here, the reduction one is this, right? It's being reduced because it's gaining electrons. This is the reduction. You want to find which one's the oxidization. To know the oxidization, you can just flip the more negative one into positive, and that's your Eox. So it's a simple step, right? 0.76, 0.34. This works. However, here, like for question 2, it won't work to just flip. You need to know which one is your oxidization, which one's your reduction. So here, it's actually written, they gave you, this is your oxidization because it's losing electrons, and they gave you this is your reduction because it's gaining electrons. So this is my Eox, this is my E reduction. So here, I can just add them without having to flip. In the last one, I had to flip because they were both reduction. I had to change one into oxidization. Here, they're already given oxidization reduction, so I can just add them and simply get 0.57. Which one is the cathode, which one's the anode? You know that oxidization takes place at the anode. That means nickel is the anode. And reduction always takes place at the cathode, so that means cathode is Ag, which is the silver. Right? The overall reaction that takes place. Overall reaction, they basically mean redox. Here's what you do for redox. You take your two reactions and put them above each other. Here they're already given above each other. What do you do? To get your redox, you should have equal number of electrons, so you can just cancel them out. Are they equal? They're not equal. So what do I have to do? I have to multiply everything here by 2. Now, can I cancel E with E? Yes, 2E, 2E. What am I left with? 2Ag plus Ni, so 2Ag plus Ni to produce Ni 2 plus and Ag. As the 2Ag, sorry, not Ag. 2Ag. You can put state symbols. This is obviously aqueous. This is nickel, so just take them from the question. Solid, Ni2 plus aqueous, and Ag is solid. That's it. Redox, you need to be able to cancel your electrons out. So you have to multiply by 2 so you can have an equal electrons. That way you can cancel out. The cathode gains 0.004 moles. Calculate the mass lost from the anode. نحن, like it would be wrong here to say, oh, the cathode gains 0.004. That means the anode loses 0.004. Okay, so I already know the moles. I can just multiply by the mole mass. No. Why is this wrong? Part C, you just found the reaction. You literally just found the reaction. إلنا نحن, the anode is going to be the nickel. This is my anode. With the cathode is the silver. So this is my cathode. If I'm losing, so if I'm getting 0.04 here, am I going to lose also 0.004? Let's look at the reaction. Do they have the same coefficient? No, they don't. So I actually have to know. You can simply divide by 2, or if you want to be fancy, those people who like to do RR and GR, you do RR and GR. Here you have 1. Here you have 2. Here now you got 0.04. 0.004. Here I don't know how much, so I put X. Cross multiply, and you get that you lost 0.002 moles. So this is the moles you're working with. And I just divide by 2. It's not that deep, Allah. So you get the moles. How do you find mass? We're talking about nickel, right? N is equal to mass divided by molar mass. The moles is 0.002. The mass we're trying to find, the molar mass of nickel is 58.7. Cross multiply, you can get 58.7 times 0.002, and you should get to 2 significant figures around this. It's going to be 0.12. Also, instead of finding moles, you could have done this. Ag was 2. It became 0.004. The mass of nickel originally for 1 mole, it was 58.7, right? In the reaction, it's 1 nickel. How much is it going to be? You can cross multiply, and you'd get the same answer. 58.7 times 0.0040 divided by 2, and you would get the same answer. Question 3. You have considered the following. They gave you reactions listed in decreasing E0 value. Complete the equation of the reactions that may take place in each of the following cases. So they gave you it like this. If it's non-spontaneous, write NS. Ag plus Fe. Let's see, is Ag more reactive than Fe? Ag is down here, Fe is all the way up here. Can you react them with each other? Is Ag more reactive than Fe? No. So obviously non-spontaneous. Cu and Ni. Realize here how they put the charged one first to trick you. People see Cu and they see Ni, like, oh, Cu is not more reactive, it's under Ni, so it's wrong. No, Habibi. We said that you check for the one that has 0 charge. That's the one that should be more reactive. So it shouldn't be Cu that's more reactive, it should be Ni that's more reactive. Let's see Ni. Ni is over here, Cu is under it. So Ni is more reactive than Cu, so can the reaction happen? Yes. So how would it happen? So easy, guys. Wallah, just swap the charges. So swap the charges, swap the states. Ni was solid, it becomes aqueous. It was 0. How much is Cu? It's 2 plus. So the 2 plus goes to Ni. The aqueous goes to Ni. Then the 0 charge goes to Cu and the solid goes to Cu. You literally just swap the charges, swap the states. Question 4. Anna and Kevin are asked to build a galvanic cell using silver and cadmium. And it's given that cadmium is, its E0 is positive 0.4. So this is getting reduced. Ag is negative 0.80. So which one has a higher reduction potential? It's CD. So that means CD would get reduced. And Ag, would it get reduced if it's negative? No, it's getting oxidized. So which one would be the anode? Always. The oxidizing is always the anode, and the reducing is always the cathode. Why am I finding this? Because you need it for the question. So which one? Cadmium is the what? Obviously. Wait. Reduction. Shit. My fault. I didn't read the reaction. Sorry. E0 doesn't necessarily mean it's for reduction. Here, they gave you the E0, but they gave you the E0 for that reaction. This reaction is actually, it's losing electrons. This is oxidization. But this one here, it has a negative potential. This is oxidization because it's losing, right? It has a negative potential for oxidization. So do you think you'd prefer to get oxidized or reduced? If it's negative for oxidization, obviously you'd prefer to be reduced. This is how you think of it. But here, back in question 1, I didn't really realize it. Here, these are reduction reactions because they're gaining electrons, right? They're reduction. But this one has a negative potential for reduction. If it has a negative reduction potential, that means it would prefer to get oxidized. And if it prefers to get oxidized, that means Zn is the anode, because always the one that gets oxidized is Zn. But over here, in question 4, they didn't write for me reduction reactions. They wrote for me oxidization reactions. So is this the oxidization potential or reduction potential now? It's the oxidization potential. And it's positive oxidization potential. That means the cadmium would prefer to get oxidized. The Ag, its oxidization, is negative. So would it prefer to get oxidized or reduced? It would prefer to get reduced. Okay? Which one gets reduced? Which one gets oxidized? The anode or the cathode? Always. The one oxidized is the anode. So cadmium is the anode because it prefers to be oxidized. The one that prefers to get reduced is the cathode. This is all memorization. Wallah. I can't. I'm trying to make you understand. I can't. You have to memorize all of this stuff. The one that gets oxidized is anode. The one that gets reduced is cathode. Write the half reaction that occurs at each electrode. So they want the one that takes place in the anode. At the anode, always it's oxidization. How do you write oxidization? You always take. Actually, it's just given. It's just. It's given. The anode is the. Okay, you just write this. Obviously, don't write this. Okay, and then the half reaction takes place at the cathode is this one. Oh, okay, no. At the cathode, sorry. Ya Allah, I apologize. It's 12:40. I'm very, very sleepy. Anyway. At the anode اتفقنا it's oxidization, right? And it's already given the oxidization. But at the cathode, it's reduction, right? But this one here, is this reduction? No, we said it's oxidization. We said this is oxidized. These are both oxidization reactions. But I just said this reaction would be preferred to be it would prefer to be reduction. I said this because its potential to be oxidized was negative. That's why I said reduction. I'm not saying this is reduction. I'm just saying it prefer to be reduced because it has a negative potential for oxidization. Anyway, عندك هيدي هون. This is the oxidization reaction. And I want it to be reduction. How do I change it to reduction, bro? Just swap them around. It's just gonna be Ag plus aqueous plus E minus to produce Ag solid. Even if you didn't have these two, at the anode, if you know it's cadmium and you know the charge of cadmium is 2 plus, at the anode it's oxidized, so it's releasing electrons. So you should have electrons here. Okay, so it starts at the anode, always it starts with 0 solid. It starts as a solid, and that solid dissolves to give ions and electrons. This is 2, so I have to put a 2 here, and this is obviously aqueous. At the cathode, the ion turns into solid. At the cathode نحن اتفقنا that Ag is the cathode, so it's going to turn into Ag solid. How do you get Ag solid? What are the Ag ions? It's Ag plus aqueous plus E minus. Calculate the net E0 of the cell. Always net E0 net is equal to E of the oxidation plus E of the reduction. We اتفقنا the oxidation is 0.4. How much is the reduction? I want to change this one into reduction. How do I change it? I just flip it around, and when you flip it, this changes into positive 0.8. So it becomes 0.4 plus 0.8 is going to be 1.2. 90% of the time when you're asked to calculate E0, you just swap the less negative one, the more negative one, into positive and then add. But the only exception that I've seen really when studying, this is the only question where they gave you one that I've seen. This is the only time they actually gave you the oxidation and then reduction. So all you had to do was just add. You didn't need to swap. Usually you have to swap them. That's why I was a bit surprised. Part D. في E كمان. In the outside circuit, the electrons flow from what to what? Electrons flow from negative to positive. Which one's negative? Negative is always anode. Which one's positive? Cathode. Anode to cathode. So, we said the anode was cadmium because it was more oxidization. And we said cathode was silver because it was more reduction. So, أكيد is going to be from cadmium to silver. How about current? Current flows from positive to negative. So, which one's positive? Cathode. So, cathode to anode. Which one's my cathode? The positive one. The cathode is the one that prefers reduction, and we said that was the silver Ag. Which was the cathode? This was the cathode. Which one's the anode? I don't know why my handwriting is this bad. Which one's the anode? Is the one that prefers oxidization, and that was cadmium. So we'll go from silver to cadmium. The cathode gains 0.008 moles. Calculate the mass lost from the anode. In the previous question, we had something like this. We had the reaction written down. Like I told you, to find the reaction, you just take your oxidation and reduction and you combine them with each other. Only on the case can you directly combine them when you can cancel the electrons with each other. You can't cancel the electrons with each other, so you have to multiply this one by 2. You have to multiply this whole reaction by 2. Before combining and canceling and writing everything down, you immediately know that it's going to be 1 CD for every 2 Ag. So that means If the cathode, what's my cathode by the way? My cathode in this case is Ag. If Ag is gaining 0.008 moles, then how much is cadmium gonna gain? It's gonna gain half of that, right? Because it's 1 to 2. I'm making your life way easier. I don't want you to write a full reaction and that. Okay? If this is 1, this is 2, that means this is double of this, right? So this is gaining 0.008, that means this one will lose 0.004. Then how do you find the mass? N is equal to m over m. You found the small amount 0.004. The mass of cadmium is 112.4. So the molar mass of cadmium is 112.4. We want to find the mass, so m over m, cross multiply. You're going to get m is equal to this. If you want to do the long way, let's do the long way. To do this, you need to find the overall reaction. To find the overall reaction, you just combine the oxidization with the reduction. And you need to multiply this one by 2 so I can cancel the electrons with each other. I can cancel now. What am I left with? Cd solid plus 2Ag plus aqueous to produce Cd2 plus and 2Ag. هيدي حتكون solid, هيدي حتكون aqueous. Okay, this is my reaction. If the cathode Ag gains 0.08, so هيدي gains 0.08. 0.008. How much is lost from the anode? Cd. بتروح على Cd. So you have 2 here, right, in the reaction, but how much was actually gained? 0.008. بتروح على anode. How much is here? 1. How much moles do we need? X. You can cross multiply and find the moles 0.004. Then, like we said, you can get is equal to 0.004 mole. N is equal to mass divided by molar mass. So 0.004 is equal to the mass we don't know over the molar mass of cadmium, which is 112.4. You cross multiply, you get 0.45. Or instead of using moles, we can use masses. How much is the mass here? It's just cadmium, which is 112.4. Over the molar, the mass, we don't know it. If you cross multiply, you're going to get also 0.45. I actually need to check this, by the way. 112.4 times divided by 2. Yeah, 0.45. Question 5. An electrochemical cell is made up by 2 half cells of zinc and silver. Okay. They gave you that Ag. This is what? Losing electrons. This is oxidation. And its potential is minus 0.8. And then here, against losing, so this is also oxidation. Oxidization. Potential is positive. They want to find E net. To find E net, you need E oxidation plus E reduction. My oxidation one, in this case, I have both of them are oxidation. So I need to swap one of them. Always, like I told you, if you need to swap one of them, swap the negative one, the more negative one, and then add. So just make this plus 0.80 and make this plus 0.7, and this is just plus 0.76, and then add them. You get plus 1.56. I think you can just put 1.56. Oh no, you need to put precede it by the correct sign. So always put plus if they say this. Then they say, where does the current flow from what to what? Okay. In this case, this one, these are both oxidation potentials because they gave you oxidization reactions for both. This one has a negative oxidization potential. If it's negative oxidization potential, that means, does it want to be oxidized? No. It means it wants to be reduced. So Ag is being reduced. This one has an oxidation potential that's positive. So what does that mean? It means it wants to be oxidized. The oxidized one, which one gets oxidized? Always the anode, right? Which one gets reduced? Always the cathode. So which one's the anode? Zn. Which one's the cathode? Ag. Very easy. Like, until now, it's just memorize these. Here they're saying the current flows from what? Always current flows from positive to negative. That means from cathode to anode, right? What's my cathode? Ag. What's my anode? Zn. So from Ag silver to Zn, which is zinc. Which is the cathode? Like I told you, Ag. Which one gains weight? The one that gains weight is the cathode. شو هالسؤال الغبي. the one that gains weight is the cathode because it's the one that actually gains weight. خلاص احفظها. Because it's the rod that lengthens. Remember that the anode is the one that reacts. Let me go back to the drawing. Here مثلا. No, it's not here. Here, with these two, the anode was CuNO3 and the cathode was AgNO3. I told you that this rod, the Cu rod, will begin to dissolve and release ions. That it was solid and it will release ions. And then here, the Ag, it would turn from ions into the solid. So its rod will actually begin to increase in weight and size. So the one that gains weight is always the cathode. When this electrode gains 0.001 moles, how many grams will the other electrode lose in weight? Same as all of the other ones. You can find, I'm going to make my life way easier. I don't like finding the net reaction. بسرعة, I see. Yeah, first I see which one's my oxidation, which is my reduction. We know that the cathode undergoes reduction. Actually, no, that doesn't, we don't care about this, actually. No difference. Here, they're both oxidization, right? We change the negative one, change it into reduction. How do you change it? Just swap them around. You're going to get Ag plus E minus to produce Ag. Hello, we have a reduction and we have oxidization. Okay. My oxidation, I'm just going to copy it over here. 2 E minus. Let me erase this. Oh, no. Zn2 plus 2 E minus. Okay. Can I directly cancel them? No. Right? I'm not allowed because I need to multiply this one here by 2 everywhere. So now I can cancel them. And if I just combine them together, I get Zn plus 2Ag plus. That's on the left side. And on the right side, it's 2Ag plus Zn 2 plus. This electrode that we're talking about that gains weight, the silver, it gains 0.001. So the silver, the Ag, gained 0.001. So it was 2, gained 0.01. How many grams will the other one lose in weight? The other one is obviously zinc. How much is the weight of zinc? I'm just going to directly do it with mass. I don't want to find moles and then multiply it over. Directly do mass. How much mass do I have in the original one? 65. I want to know how much mass. So I cross multiply. You're going to get 0.01 times 65 divided by 2. 0.0325 to two significant figures, 0.033. That's it for 4.5. هلا 4.6. Oxidation numbers. 4.6. It's a table. Memorize the table. You're gonna get full in this section. So easy. I'm gonna write it down. Let me cut to me writing the table down. Okay, so this is the table. Very easy. Species, oxidation number, what is its exceptions, and what are some examples. We'll start with elements. The oxidation number of any element on its own is 0. No exceptions. Some examples would be like H2. Just hydrogen gas would be on its own, would be 0. Oxygen gas would be 0 because like on its own. Magnesium would be 0. Zinc would be 0. Carbon would be 0. Whatever. On its own, it's always 0. Any element or compound on its own is 0. Simple ions would be the charge. مثلا Na plus, or no, N2 plus would be equal to 2, its oxidation number would be plus 2. Na plus would be equal to plus 1. What are some? Yeah, just Cl also. Cl minus would be minus 1. Elements in compounds, and there's a long list. Fluorine would be minus 1. Okay. Group 1 metals like Na, obviously Na plus is always like plus 1. Group 2 like magnesium, Mg2 plus is always going to be plus 2. Aluminium is going to be plus 3. I'm sure many of you know this already. Oxygen is going to be minus 2, except for when it's with a peroxide. Some people ask me what's a peroxide. A peroxide is anything that has 2 O's. Like H2O2, in this case, the oxidation number of each oxygen would be -1. I'm not saying total O2 is -1. I'm saying each oxygen in this case would be -1. Instead of -2 each, it would be -1 each. Also, except with metals, except with chlorine, they don't ask this really. Cl, Br, and I, it's usually -1. Except with oxygen and fluorine, then you'd actually have to calculate it. Like, there's nothing you have to memorize. You can calculate it. I'll show you how you guys calculate it. You'd see also in this quiz you need to calculate. And then hydrogen, it's usually +1, except with metals. With metals, it would be -1. Okay, هلا let me show you the quiz. Determine in which of the following does sulfur have an oxidation number +2. Here, SO3 2-. This is how you do it. If you want to calculate the oxidation number of something, always the total oxidation number is equal to the charge of that compound. What's the charge? -2. Sulfur, we're trying to find it, so let's call it X. Oxygen, I have 3 of it. And how much is each oxygen? Each oxygen is -2. So I'm going to do 3 times -2. So X -6 is equal to -2. So how much is the oxidation number of sulfur in this case? It's going to be 4. Do we want to, sorry, you have to put the sign, always sign, huh? Always put the sign, +4. Is it +2? No. So that means this is not my answer. SO4 2-. Let's take this now. We're trying to determine sulfur, so we're going to determine it by X. We have 4 oxygens, so 4 times each oxygen. We know oxygen is always -2. How much is the total oxidation number of the compound? -2. So it's going to be X -8 is equal to -2. You're going to get X is equal to +6. Is that +2? No. How about here, S2O3? We have 2 S this time, 2 sulfurs, so we're going to write that as 2X. O3, so we have 3 oxygens. How much is 3 oxygens? Always, each oxygen is -2. How much is the total charge of the compound? -2. You can get 2X -6 equal to -2. You can get 2X is equal to 4. So X is equal to +2. Don't we want +2? Yes. Here, the charge is going to be -2. And here, it will be -12. It would be +5. We don't want that. Okay, so this is our only correct answer. That's it. This is the only way to calculate oxidation numbers. Like, it doesn't get harder than this. Okay, here give the oxidation number for each element in the following species. Okay, NO2. How do you calculate it? N, we're trying to find it. X. We have 2 oxygens, so we're going to replace, it's going to be 2 times, how much is each oxygen? -2. Equals the total charge of it, it's 0. X -4 is equal to 0. So how much is nitrogen going to be equal to? 4. +4. +4. You know, O is always -2, so we can just skip that. HClO4. We know oxygen is -2. H is +1. And we know that Cl is usually -1 except with oxygen and fluorine. So in this case, we can't say that Cl is -1. We actually have to calculate it because it's with oxygen. How do I calculate it? Hydrogen we know is +1. Cl we know it's X. O4, that means it's 4 times, how much is each oxygen? -2. Equals the total charge of it, 0. So you're going to get X 1 plus 4 times -2 is actually -7 equal to 0. So you're going to get X equals 7. So we already know O is -2, hydrogen is -1. How much is Cl? +7. MnO4. We want to find obviously manganese. O4. Let's call manganese X. We have 4 O's, so 4 times -2 equals the total charge -1 because it's a negative. You're going to get X is equal, again, +7. So your manganese is +7. And O we already know is -2. We have it memorized. Question 3. Balancing, it's not required. Skip this. Question 4. Here, they want us to arrange them in increasing order of oxidation number of tungsten. How do you find it? Obviously, tungsten on its own is just 0. So the lowest will be just W on its own. Now, let's calculate the oxidation number of each one. Let's say W2O3. How much is it going to be here? W2, so it's 2 tungsten, so 2X. Plus, what? 3 O's, so 3 times -2, equal to the total charge, 0. So you're going to get is X is equal 3. Then you have WCl4. X plus 4 times -1. Remember, it's Cl is -1, huh? So you're gonna get x, it's equal to 0 because the total charge is 0, so x is equal to 4. WBr5, W is x, Br is 5 times each Br, which is -1. Remember, CLBr and I are -1. Is equal, obviously, to 0 because the total charge is 0. So that means x is equal to 5. Plus 5, huh? I should be putting plus. I keep forgetting to put the plus on. Then for W2OCl2, O2Cl2, Cl this time is with oxygen. For this one, even though you have an oxygen with it, you're still gonna use Cl as -1. I've been staring at it for 5 minutes, and I'm comparing it with the one we had in question 2. I think it's because here in question 2 you had Cl before the O, but here you have O before the Cl. I think that makes a difference. Again, they won't get these types of trick questions in the exam. But if you do get it in your exam, it's gonna be more straightforward than this. But على كل الأحوال, I think if you see the Cl after the O, then you don't change it, you keep it as -1. So W is x plus 2 times each oxygen is -2 plus 2 times each Cl is -1 equal to the total, which is 0, صح? So you're gonna get x minus 6 is 0, so x is equal to 6. So in increasing order, it will be W 0, so it's 0, right? Because it's an element on its own, remember it's always 0. Then it's plus 4, then it's plus 3, sorry, W2O3, then WCl4, which is plus 4, then so on and so forth, right? Plus 6. For the last question of the day, I've been recording since 1:30 p.m. Here you have, I want to find the oxidation number. Okay, O and Na2O. Remember that oxygen is normal unless it's with metals or fluorine, right? And sodium is a metal, so it will be different. It won't just be -2. Even though the answer is -2, you can't just say -2 directly. Na2O. Na2O. It's a group 1 metal, so it's going to be 2 times, how much is a group 1 metal? It's always +1. Plus O, let's just call it X. And how much is the total charge of it? Is 0, right? So 0. So X is going to be equal to -2. N in HNO3. H is +1. N is X. And O is -2. So 3 times -2. How much is the total? 0. So you can get X is equal to 5, plus 5. Cl and ClO3 minus. Cl is X plus O3 minus. Yeah, see here Cl came before the O. O3 minus, so 3 times. How much is each O? -2. Equal to the total charge. Now it's -1, right? So you're going to get X is equal to plus 5. H and H2. When it's just an element on its own, even if it's H2, it's 0. I can't believe it. I'm actually done. Alhamdulillah. Thank you so much for watching. Good luck in your chemistry periodic.